Most foods come with a clear warning: eat them quickly or throw them away. Bread grows mold, fruit rots, and even canned goods eventually expire. Yet there is one food that quietly ignores these rules. Honey can sit on a shelf for years, decades, even centuries, and remain unchanged. This is not a modern preservation trick or the result of artificial additives. It is something honey has always done naturally. From ancient civilizations to modern science labs, honey has consistently proven that time alone cannot destroy it. Understanding why reveals a story shaped by chemistry, biology, and the remarkable instincts of bees. To understand why honey does not spoil, it helps to first understand why food spoils at all. Spoilage occurs when microorganisms such as bacteria, yeast, and mold begin to grow. These organisms feed on food, break it down, and produce waste products that alter smell, taste, and texture. Warmth, moisture, and oxygen help them thrive. Most foods contain enough water and nutrients to support this microbial growth, making decay inevitable once microbes begin to multiply. Honey, however, creates an environment where these microorganisms simply cannot survive. This is not because honey lacks nutrients, quite the opposite. Honey is rich in sugars. What it lacks is something even more important: usable water. Honey has an extremely low water content, averaging only about 17 to 18%. While this may not sound dramatic, it makes all the difference. Microorganisms need water to live, grow, and reproduce. In honey, the water is so tightly bound to sugar molecules that microbes cannot access it. This creates what scientists call a low water activity environment. Even if bacteria or mold spores land in honey, they become dehydrated almost instantly. Their cells lose water through osmosis, causing them to shrink and die. In simple terms, honey pulls the life out of anything trying to grow inside it. This alone would make honey remarkably stable, but it is only one part of the story. Another reason honey resists spoilage is its acidity. Most bacteria prefer environments close to neutral on the pH scale. Honey, however, is acidic, with a pH ranging between 3.2 and 4.5. This level of acidity is comparable to vinegar or citrus juice. Such an acidic environment is hostile to many microorganisms. Even if a microbe somehow survives the lack of water, the acidity interferes with its internal processes. Enzymes fail to function properly, and essential chemical reactions slow down or stop entirely. Together, low water content and high acidity form a powerful double barrier against spoilage. The story of honey's longevity would not be complete without the bees themselves. Nectar collected from flowers is not honey when it is first gathered. Nectar is mostly water and would spoil quickly if left untreated. Bees transform nectar into honey through a precise and elegant process. Inside the bee's body, enzymes are added to the nectar. One of the most important enzymes is glucose oxidase. When nectar is deposited into honeycomb cells, glucose oxidase reacts with glucose and oxygen to produce gluconic acid and hydrogen peroxide. Gluconic acid increases honey's acidity, strengthening its resistance to microbes. Hydrogen peroxide acts as a mild antiseptic, killing bacteria that might survive the other defenses. These substances exist in small amounts, but together they form a natural preservation system. Bees then fan their wings to evaporate excess moisture from the nectar. Over time, the water content drops, sugars concentrate, and nectar becomes honey. Once the honeycomb cells are capped with wax, the honey is sealed and protected from external moisture, locking in its stability. Sugar is often associated with decay, but in high concentrations it does the opposite. Long before refrigeration, sugar was used to preserve fruits in jams and jellies. Honey takes this principle to the extreme. Honey is made up of roughly 80% sugars, mainly glucose and fructose. This high sugar concentration creates intense osmotic pressure. Any microorganism that comes into contact with honey rapidly loses water from its cells. This process, known as plasmolysis, damages cell structures and prevents reproduction. This is why honey has historically been used not only to preserve food, but also to treat wounds. Its ability to inhibit bacterial growth is not accidental. It is a direct result of its chemical composition. The idea that honey lasts forever is not entirely a myth, but it does come with conditions. When stored in a sealed container, away from moisture and excessive heat, honey remains chemically stable for an extremely long time. Its flavor, aroma, and color may slowly change, but it does not rot like other foods. Ancient honey found in tombs survived because it was sealed and protected from humidity. The same principles apply today. Modern jars of honey, when properly stored, can remain edible indefinitely. Food safety organizations may label honey with expiration dates, but these dates refer to quality, not safety. Honey does not become dangerous with age. It may simply lose some of its subtle flavors or aromas over time. Honey's ability to resist spoilage is the result of many small advantages working together. Low moisture deprives microbes of life. Acidity disrupts their survival. Enzymes create natural antiseptics. Sugar locks away usable water. Even the behavior of bees plays a role, transforming fragile nectar into a food designed to endure long periods of scarcity. What makes honey truly remarkable is that it achieves all of this without human intervention. No preservatives are added. No special storage methods are required beyond keeping it sealed and dry. Honey lasts because it was meant to last. In a world where most things are temporary, honey stands as a quiet exception. A natural food that resists decay, carries history within it, and remains unchanged as time continues to move forward. Thank you for watching.